Hi, this is Ramachandran from onlinemathforall.com. In our website onlinemathforall.com, students can find video tutorials like this, which will be much useful for them to prepare for competitive exams like GMAT, GRE, CAT, and more. Okay, this video is about Quantitative Aptitude Tricks Part 2. Here we are going to see some math problems which are frequently asked in competitive exams. And also we are going to see the tricks to solve this kind of math problems. Okay, we have a problem on the board. Okay, let's go through the problem. That is, if log x to the base 2 positive log x to the base 4 positive log x to the base 16 is equal to 21 over 4, find the value of x. So we just find only one information, that is log x to the base 2 positive log x to the base 4 positive log x to the base 16 is equal to 21 over 4. So from this we have to find the value of x. When students have this kind of problems on logarithm, so immediately what they will do is they will try to apply the fundamental law of logarithm on the right side of this equation. So because whenever we have logarithms are added, we can just take only one logarithm and we have to multiply the terms given here. So here the thing is not like that, because for these three logarithms, for example, one second, I'll show you here. Okay, for example, we have log a to the base 10 positive log b to the base 10 positive log c to the base 10. So now we have three logarithms added. So for this one we can write log a times b times c to the base 10. So here we have three logarithms added. I just take only one logarithm and I multiply these three values. So here I can use the fundamental law. So because we have base for the first logarithm, second logarithm, third logarithm, for all the three logarithms we have the same base, so we can apply the fundamental law, then we can multiply these three values. But in our problem we have three logarithms added, but the base for the first one is 2, base for the second one is 4, base for the third one is 16. So here we cannot apply the fundamental law because the base for all the three logarithms are not same. So we have to try some other trick to solve this one. Okay, first let me take the given information and I'll show you how to solve this one. Log x to the base 2 positive log x to the base 4 positive log x to the base 16 is equal to 21 over 4. Here for each logarithm I just assume there is a denominator 1, because for any value there is a denominator 1. Usually we don't write the denominator 1, but even if we write 2, so there is denominator 1, because when you divide 2 by 1 it will be 2. So I assume there is denominator 1 for each logarithm. Now what I am going to do is okay, first let us consider the first part, log x to the base 2 over 1. Here we have logarithm at the numerator. Now I want to write this logarithm at the denominator. So if I try to write this logarithm in the denominator, I have to interchange these two, x and 2, to be interchanged. Okay, I'll show you in the next step. So 1 over log 2 to the base x. I hope the students can understand now, because now I have written this logarithm at the denominator. When I write this logarithm at the denominator, these two have to be interchanged. So now we have log at the denominator. In this situation the numerator will be 1. The same thing I am going to apply for this one, for this one. 1 over log 4 to the base x positive 1 over log 16 to the base x is equal to 21 over 4. Okay students, the next step what I am going to do is I am just going to write this 4 as 2 to the power 2, because the value of 2 to the power is 4, and I am going to write this value 16 as 2 to the power 4, because the value of 2 to the power 4 is equal to 16. Okay, I'll show you this on the next page. So 1 over log 2 to the base x positive 1 over log 2 to the power 2 to the base x positive 1 over log 2 to the power 4 to the base x is equal to 21 over 4. 1 over log 2 to the base x positive 1 over 2 log 2 to the base x because I have taken this power in front of the logarithm, because there is a fundamental law in logarithm, that is log m to the power n is equal to n times log m. That is what I have applied here. The same thing I apply here. 4 times log 2 to the base x is equal to 21 over 4. Okay, so the next thing what I'm going to do is, here we have log 2 base x, log 2 base x, log 2 base x, but here we have 2 multiplied, 4 multiplied. If I have same denominator for all the 3 fractions, I can take common denominator and I can add the numerator. Since I would like to have the same denominator, so instead of this 2, I need 4. Here also I need 4. So since I need this 2 as 4, I'm just going to multiply by 2 at both numerator and denominator. 1 second. The second fraction, I multiply the numerator and denominator by 2. And in the first fraction, I multiply by 4 at both numerator and denominator. When I do so, 4 over 4 times log 2 to the base x positive. The second fraction we have 2 over 2 times 2 will be 4 log 2 to the base x positive 1 over 4 times log 2 to the base x is equal to 21 over 4. Here for all these fractions now we have the same denominator, 4 times log 2 to the base x, 4 times log 2 to the base x, 4 times log 2 to the base x. Now I can take the common denominator 4 times log 2 to the base x. I have to add the numerators 4 times 2 times 1. When I add the numerators, 4 times 2 will be 6, 6 times 1 will be 7. Okay, I'll proceed the next step on the next page. So I have added all the numerators, so 7, and I have the common denominator, that is 4 times log 2 to the base x is equal to 21 over 4. Now I am going to take reciprocal on both sides. When I take reciprocal on the left side, it will be 4 times log 2 to the base x over 7. Here 4 over 21. Here students, here we should not interchange these two. So because I'm not going to write the logarithm that we have at the denominator, I'm just going to write that at the numerator. It's not like that. I've taken reciprocal on both sides. When you take reciprocal on both sides, you should not interchange these two. I hope the students can understand this step. Now I need to solve for x. So for that, what I'm going to do is, I'm just going to multiply by 7 on both sides. So when I multiply by 7 on both sides, 7 will get cancelled. Yeah, 1 times 7 will be 1. 3 times 7 will be 21. So 4 times log 2 to the base x is equal to 4 over 3. Now what I'm going to do is, I'm going to multiply by 1 over 4 on both sides to get rid of this 4. When I do so, this 4 and 4 will get cancelled. This 4 will get cancelled. So we get log 2 to the base x is equal to 1 over 3. Okay, next step what I am going to do is, we have log 2 to the base x is equal to 1 over 3. Now I am just going to take this part, log to the base x, to the right side of the equation. So whenever we take logarithm from one side of the equation to other side, we have to ignore log. We have to consider only the base on the other side. Here we have the base x. Students, please listen to me carefully. Whenever we take log from one side to other side, we have to ignore the logarithm and we have to consider only the base on the other side. I'll show you on the next page, next step. So we'll have 2 is equal to, when this part, 1 second. When this part goes to the right side, we have to consider only x, and this 1 by 3 will become power. I'll show you here. So 2 will be left on the left side. So we'll have only x. This 1 by 3 will become power. So the next step what I'm going to do is, I'm just going to take this 1 over 3 to the left side. It will be 2 to the power 3 is equal to x. The value of 2 to the power 3 is equal to 8. So the value of x is 8. I hope the students can understand and how to solve this kind of problems on logarithms in competitive exams. Okay students, for more videos like this, please visit www.onlinemathforall.com. Thank you.